Oops. Let's see, is that referencing the? Let's see, it needs to be. Is it F40? 22.
That's
The
not
drop
right.
over distance.
No, I don't want drop over distance. I want the difference between the celestial theodolite results and the globe predicted geometric results. Because the celestial theodolite is claimed to give the geometric angle to the mountain. And it's claimed to never match the globe geometric prediction closer than it matches the flat Earth geometric prediction. So
Jesse.
1396 minus 1398 is minus 2, right? So
yes, and the difference between this, right? The difference between this F5, or no, I'm sorry, H5 and H14 is created by this difference here, right? So when we do our aired sum, we get the half of the central angle. That's what's predicted as drop over distance. So we're off by 24. You guys are off by 46. I'm sorry, 45 meters. So
which we don't agree to because we think that
I don't care if you agree to it or not. That literally means nothing to me.
How would you respond if the Globers were attributing some math to flat Earth that no flat Earther agreed to? Would you call that a straw man?
Ruhif tried to do that earlier, and I rejected the premise. If you reject the premise, you don't need to be here arguing it endlessly over nothing. Like, do you wonder why I don't talk to Ruhif endlessly? Because he rejects the premise and doesn't argue it. When it comes down to it, he just says, "That's rubbish, mate." We just went over it not being rubbish. The fucking French were doing the same thing. How could it be rubbish? It's only rubbish because it doesn't give a geometric alignment that's close to the globe. If the measurements came out reversed and it aligned with the globe, all of you globe lads would immediately accept it and use the geometric position. It would be the greatest thing since sliced bread.
So, no chance you'd be willing to add in a
still.
Mic check. No chance you'd be willing to add in a line in the pink section called Globe Earth Results, so it's obvious to everybody, and add a line called How Globers Want It Done, or whatever. I mean, you don't have to say
this is a really weird social shame manipulation thing that you're trying to play, and all the information you're requesting here is right here, and we do presentations every Monday and openly discuss this with anyone who has questions. No one's hiding anything. Everything that you've requested in the sheet is actually already existing here, and now you're turning this into a weird thing where you're like, if you don't add this one thing, you're not honest. And honestly, dude, that means nothing to me. I've already done the best I can to make this as open and public as possible. So to be like, do this one last thing to show this one other relationship where this is going to be off by 2, but then never acknowledge why it's off by 2 because there's no globe elevation geometric alignment with the star at the time of occlusion. Like, never acknowledge that part, but you want me to do this one solid favor for you. Like, dude, you go make your own sheet. Go do your own presentation on where you think the shit should be.
I mean, it is weird, Jesse. Like, you don't actually acknowledge the results.
What do you mean? Which results?
You don't find it strange that the shared error between flat Earth prediction and globe Earth prediction is actually the drop over distance, the half gamma?
Well, the important thing is, can anybody occlude a star, put stellarium on the peak with atmosphere off, read the altitude angle from stellarium for that star, and know that that is, within a small margin of uncertainty, the true angle to that mountain peak? The answer is sometimes that angle matches the globe within 2 meters. Sometimes it matches a tiny globe. Sometimes it's 1,800 feet above the flat Earth prediction.
Listen, so here where you're saying it matches the globe, that's a different comparison. We're comparing geometric alignments. If your hypothesis of refraction were correct, the gamma difference error between us would be different. That's not even what's shown. So that's completely unfounded. And again, you're just going to not acknowledge any of the significance of it and try to turn it around to like, oh, you're not acknowledging what the globe would say, and even though the globe predicts it's already above it. Like, even for your measurement, it predicts the refraction amount predicts that the star would have emerged it would be 3 arc minutes above the peak. It should have already emerged like 27 seconds earlier. That doesn't happen. No acknowledgement of that ever. Just straight to,
go to that
hey,
one?
hey, if I subtract these two differences where there's a shared error and it's close to, in this case where it looks like that would be the drop over distance for what the globe would predict, I'm going to use that as my example. That's just rhetoric and retarded. Now, you wanted to go to Berlin or whatever?
Yeah.
Look at it.
All right. Let's see if you can
arc minutes
acknowledge
of refraction.
So
you see that,
here
Jesse?
we have. What's that?
Do you see that?
It looks like we have a globe error of 2.5-ish arc minutes and a flat Earth error of over 12 arc minutes, right? Am I seeing that right?
You have a position of a star that wasn't measured because it was geometrically occluded by a mountain, which had to have the full arc length traversed before it actually emerged. That's why the geometric intersection errors are this, right? And the star didn't emerge 17 seconds earlier with the refracted position. It played no role in this.
So was the angle returned from Stellarium at the peak with atmosphere off closer to flat Earth prediction or globe Earth prediction?
Flat Earth.
Okay, what was the globe Earth predicted angle that globers approve of?
The geometric angle is for the mountain peak would be 43 arc minutes, and the intersection difference between the true position is 22 arc minutes.
You see where he's getting that number from, Jesse?
Yeah,
He's subtracting the refraction.
Yeah, and then he's trying to just look at the apparent position and make it about that, and then hinge it on the globe, like another appeal to authority. Only the globe lads would use this position, which is already predicted that it would be above it. Never happens. Then in no case has it ever emerged earlier. But it's like somehow we still have to do this rigmarole. In no case is the half gamma offset proportional to the refraction amount.
Can you go to North Peak, please? Thank you. So that 517 meters of error, that's huge. That's almost 1,800 feet, right?
And the globe is off by 800. If you add those two together, you get the drop over distance amount. That's the half gamma. So we're off because at the end of that central angle, there was an occlusion that occurred, and the globe was off by this much. We get left over with the remainder. Deriving triangles based off of the off of the true positions at that time. 1 second, I'm almost done. Is based off of this intersection error difference. This is what creates it. Go ahead.
You keep saying the globe, but you're pointing at something that no glober supports.
No glober supports it, but the other end of but the add total of that is the half gamma over the arc length. I could give a fuck if other globers support it. It doesn't mean anything. If they don't support it, that's because they don't understand that relationship is mandatory.
So you understand the globe model better than all globers?
Apparently.
I mean, oh. So how would you
if no one's willing to accept this half gamma relationship, then they're disavowing their own globe because it's proportional over every arc length. That's exactly what it is. It can't possibly be a straw man of it if it splits the error between the two and it equals the drop over distance amount, the half gamma amount between them. Can't possibly be an error. Hold on, can't possibly be an error if I can derive what the globe predicts off of positions of the stars. That's what we went over earlier tonight in the presentation for the physical elevations. We can derive all of that from the supposed offset when correcting it to flat Earth, and we could also do the same when we convert it to what the globe would predict, but that would make the flat Earth one off by the amount of drop over distance. So, like going to this peak, like your go-to, why is this off by this amount? That and all that stuff. I've answered this multiple times now that we've understood the relationship of the gamma or half gamma relationship to the measurements. This is left over because the star got occluded at the end of that arc length for the observer. This is the leftover amount because the globe was off by this much for their geometric alignment. Saying that you don't agree with that is irrelevant. The math is the math and it's proportional. It exactly represents the globe. If it represented a different number that wasn't half gamma, then it wouldn't be representing the globe, and that would be a straw man.
So let's just say, for the sake of, we're obviously not going to agree on your method of representing the globe, which is bizarre because, anyway, let's just say, for the sake of discussion, that we both agreed Earth was flat. Let's just look at the green here. How did that 517 meters of error happen? That is way, way, way outside your own error bars for that reading, right?
It's left over by assuming that there's curvature on the ground.
Oh, hold on a second. What do you mean?
That's what the half gamma relationship. That's how it comes out.
Oh.
You can't just that's what produces the error. So saying like assuming it's flat, we're using the celestial sphere model. So the angular relationship between these is always going to be, it's still going to be the same situation. And the implication to the offset is because the celestial sphere doesn't represent the ground. The stars don't actually go beneath your feet. There's no actual curvature. So there would still be an offset while using the celestial sphere model that's following 60 nautical miles per degree plus or minus lattice variance at 15 degrees per hour. Still going to be there. It's a product of the geometric relationship between the arc length and the gamma and the half gamma relationship of that arc length. even in the
So
sky. That's what we did. Look, real quick to show you this. We derive the same thing from just the positions of the stars in the sky, from taking observer location and peak location where the star's at. Subtracting that difference gives you the arc length. I'll put it on Pike's Peak so it's more familiar real quick. Um, gives you that same arc length. So what you would be asserting as, you know, drop over distance for a physical model, that air is going to come out of that regardless, because the sky and arc length relationship to the half gamma is the same in that. So it's going to be proportional no matter what. It's always going to read this even if the Earth's flat, because we're using this coordinate system to represent it.
well,
In other words, the whole entire arc length, right, from the observer to the peak, right, 27
Yeah.
on Pike's Peak.
Like, yeah.
Okay, so it's
Like,
27 arc minutes, Jesse. Do you understand that, right? So that's the full gamma.
I'm
Right?
I'm
With me
still
so far?
I'm
With me so
still
far?
I'm still lost on Alan's answer to my last question, which I think I specified specifically for the sake of discussion. Let's say we're
I emphasize again, free to join.
gives you the arc length. I'll put it on Pike's Peak so it's more familiar real quick. Gives you that same arc length. So what you would be asserting as, you know, drop over distance for a physical model, that air is going to come out of that regardless, because the sky and arc length relationship to the half gamma is the same in that. So it's going to be proportional no matter what. It's always going to read this even if the Earth's flat, because we're using this coordinate system to represent it.
well,
In other words, the whole entire arc length, right, from the observer to the peak, right, 27
Yeah.
on Pike's Peak.
Like, yeah.
Okay, so it's
Like
27 arc minutes, Jesse. Do you understand that, right? So that's the full gamma.
I'm
Right?
I'm
With me
still
so far?
I'm
With me so
still
far?
I'm still lost on Alan's answer to my last question, which I think I specified specifically for the sake of discussion. Let's say we're both flat earthers. We
That's
don't
why is
need
there
to
an error? He's explaining it to you, and I'm trying to also explain it to him. I'm trying to simplify it.
let,
It's
let
a
me let me see
product
if I
of
can
using the celestial sphere.
let me see if I can steelman his position and his argument. Are you saying then that Stellarium does not give the true geometric angle to the peak when used
Nope.
according to the celestial theodolite? You're not saying that? So it does give the true angle.
With respect to 50 or 60 nautical miles, 15 degrees per hour, it's set at that rate, you know, plus Lati variance. That's where it's predicted to be. Now, at the end of that arc length, that's all there is. There's just this distance between the observer and the peak on the ground and in the sky. We can derive this same offset difference from just the position in the sky. The difference here is an artifact of the ground not being flat. So this would still be the same relationship, because the celestial sphere is still based on 60 nautical miles per degree, like that angular relationship. As we were going over earlier, someone said that the radius of the celestial, I think it was Ruhif actually, that said that the radius of the celestial sphere was set to 6,031 or 6,371,000 meters or whatever, you know, the radius of Earth, which would, you know, that's how they could make the celestial and terrestrial sphere 1-to-1. So in doing that,
Exactly.
from geocentric to topic centric, the whole model is based on that. So if the Earth is flat and we're using occlusions to based on that system to reference, you know, where the star should be at, you're going to get these you're going to get these
You're gonna get an error.
differences. So actually, to answer your question, you're right. I did kind of misspeak. To answer your question, the relative to the observer, the star's true position at that time is whatever the rise over run to the peak is, because that's the only, like, that arc length there. If you were to do a complementary angle and figure out, like, you know, the reverse of it, there's no other drop or distance that the star could move. It already got occluded. So it's like to complete a circle and to have it, you know, come back into the same spot in the night or whatever, to get that relationship, it can't be different. So we're still going to have the same offset based on that relationship of the coordinate system.
Alan, could you pull up
And
that diagram? Oh, sorry.
yeah, so to answer your question, Stellarium reports where the star should be for an observer based on 60 nautical miles per degree, 15 degrees per hour. And what the occlusions show is that the star's true position is not actually at that location relative to the observer. Otherwise, the occlusion would have happened earlier because the Earth would be a globe and that mountain would be lower as well.
So let's say I'm a flat earther and I'm going to use the celestial theodolite and I see a mountain. I'm going to climb it and I want to know, how much food I need to take. Okay. I need to know how high the mountain is. I occlude a star. I put stellarium on the peak. I turn off atmosphere. I read the star angle. I put that angle into tangent. I multiply it times the distance. In the case of North Peak, I will be off by 1,800 feet, right? In 1795 or something. Feet.
Yes.
So what caused that? Is there another step I need to do as a flat earther? Remember, I don't believe in the globe for this discussion.